Hello, in this video we're going to explain the oscilloscope and the function generator along with the digital multimeter and how they work using virtual equipment in multisim. We'll start first by placing the equipment using the simulate menu, instruments, and then pressing or clicking on Agilent function generator. So this is our virtual function generator. Next we're going to press simulate instrument and choose Tektronix oscilloscope. Now if you double click on the function generator, you will see that there's two outputs in here, or two ports that we can connect to the function generator. Observe that the bottom one says output, so this is the output of the function generator, or this is where we can read or use the signal generated by our function generator. For that, we're going to connect it to channel 1 of the oscilloscope, which is right here. This way we'll be able to directly generate a signal from the function generator and visualize it using the oscilloscope. So after doing the connection like that in the background, we're gonna run the simulation, power on our function generator. By default, it's set to a sinusoidal signal. You can change that by pressing on the square icon here or the triangle. So this way we can change the shape of the signal. Before doing that, let me also power on my oscilloscope and then press auto set. So this way you will see the variation of the signal as we move on. Now I'm gonna use the knob of channel 1 along with the position knob to zoom in or out along the time axis or the voltage axis. For that, I'll first click stop. This way I'll pause the simulation, and then we will zoom in along the time axis and along the voltage axis by rotating the knob simply. You can also use the arrows from the keyboard. It's a bit easier if you do that. So control the knobs through the arrow buttons on your keyboard. So currently we're supplying or generating a rectangle signal of 100 millivolts peak to peak. Let's go back to the sinusoidal signal. Notice that the oscilloscope is currently stopped because we pressed the run/stop button. So let me press it on it again. This way we'll see the signal simultaneously. So we'll choose a sinusoidal signal, and now I want to control the amplitude by pressing on amplitude, and then I'll press on the left button here to move the cursor to the highest significant power. And then I will control the knob so that I will supply 5 volts peak to peak. Again, you can do that on the keyboard, from the keyboard, or using the mouse. So this is 5 volts peak to peak sinusoidal signal. I will press frequency here to control the frequency of the signal. Again, you can use the cursor and the knob to adjust the value right here. I'm going to keep it as 1 kilohertz. Now to control or modify the offset, you will press offset, and then by default we have 0 DC offset, 0 volts offset. You can modify it similarly using the cursors to move them around, along the digits here and the knob. So I'm going to go back to the amplitude menu to review the settings of the function generator. We have the amplitude set to 5 volts peak to peak, the frequency being 1 kilohertz, the offset is 0, and the shape of the signal is sinusoidal. Now I'm done with my function generator. I can close it. That doesn't mean it's going to be off. It's going to be turned off, but it's still there in the background. Next, I'm gonna auto set my oscilloscope. Press on auto set. I had to click stop to stop the simulation and then run it again. So for that, I'm gonna press on the stop button, and then again I'm gonna use this knob to zoom in or out along the y-axis or the voltage axis, and this knob to control the number of cycles I can see. Next, I will press the measure menu, which will help me measure different parameters corresponding to the signal. So I will configure the first window here to display, for example, the frequency, and then I'll press back to configure the second measurement to read the mean of the signal or the average. Remember, for an AC signal, an AC sinusoidal signal with zero offset, the mean is going to be 0. Here, what's the oscilloscope is displaying is 200 nanovolts or negative 200 nanovolts, but if you round that off, you can say that the mean is actually 0. Compared to the 5 volts peak-to-peak voltage that we're supplying, 200 nanovolts is very little, so we can round it to 0 volts. Now I'm going to configure the third measurement here to display the peak-to-peak of the signal, and then I'll go back again. Finally, I will display the cycle RMS value, which for a sinusoidal signal of 5 volts peak-to-peak with 0 DC offset turns out to be 1.77 volts. So now I'm going to press back, and then for the fifth window, I will show you that there are different parameters that we can read, including the frequency, period, mean, peak-to-peak, cycle RMS, minimum value, maximum value, rise time, fall time, and so on. So now I'm going to press back again. You can turn this the last measurement off since we're not using it, so let me choose none and then press back. So now the screen currently shows readings of the signal under AC settings or AC coupling. To change the coupling of the oscilloscope, we will press on the channel that we have the signal connected to. In our case, it's channel 1. And then it's actually DC coupling currently. So to change the coupling of a channel, press on the channel menu, for example, channel 1 menu, and then toggle the button here. Currently, I've changed it to AC coupling. The readings will not change if I press on measure again, and the reason why is because I don't have a DC offset. So if we don't have a DC offset, then the readings under AC coupling and the readings under DC coupling are the same for this case. Now, in the next step, what I'm going to do is add a DC offset to my signal by pressing or double click on the function generator and then pressing offset. I will change it to say 1.5 volts. Now I'm controlling the decimal digit. So next I'm gonna press on this arrow to move to the I was controlling the integer. Now I'm gonna control this digit right here to set it to 5 actually, so it will be 1.5 volts DC offset. Okay, now I'm going to close this window and then run the simulation again. So I will press on run to continue with the reading. You can pause it as well by pressing on the run stop. Let's check the coupling currently before we forget. Currently it's AC coupling. Okay. So we'll press measure. Notice that the frequency is 1 kHz, which is what we set it to. The mean is still 0. It's 20 microvolts. So again, you can round that to 0 volts. Because remember, we're under AC coupling. So when we are under AC coupling, we only look at the alternating signal. That means the DC signal is being ignored, or the DC part is getting ignored, meaning the offset that we supplied through the function generator is getting ignored in the readings here. The peak to peak has nothing to do with the offset, it's still 5 volts peak to peak. The cycle RMS is still 1.77 because it's looking at the signal without the offset. Now I'm gonna adjust the coupling to DC coupling. Remember, to adjust the coupling, you simply need to click on the channel menu, channel 1 menu, and then press here on the coupling. And after that, I'll press measure again to go back to the measure menu. You will observe that, see, I need to run the simulation, run the simulation here first before the readings get updated. I have to click run. And then again, I'm gonna press stop and then run. Okay, now observe, let me pause it a little. Now observe that the frequency again hasn't changed because it has nothing to do with the coupling. The mean, now we are under DC coupling, so the mean is equal to the offset, which we chose to be 1.5 volts. So that's the average of the signal. The peak to peak didn't change, it's still 5 volts peak to peak. The cycle RMS is 1.77 volts. Okay, now we can verify all of these measurements through calculations, if applicable, and all the formulas are available in the lab sheet. Let's look at, for example, a square signal. A square wave signal with 0 offset. I'll control this digit, set it to 0. Okay, now we have 0 offset, square wave of 5 volts peak to peak. So for that, the mean is 0, the peak to peak is 5 volts, and notice that the RMS is 2.5 because the RMS value for a square wave signal is equal to the peak value, which is, in our case, is 2.5 volts. So this concludes the tutorial for the function generator and the oscilloscope. I will now remove the oscilloscope and connect in place of it a multimeter, like so. Remember, the output is the bottom port here. I'll connect it to the multimeter, and I will have to place a ground. So I'll go to the sources group and then choose power sources and ground. Now, to be able to do some readings, I'll have to double click on the multimeter, click on run to run the simulation, and make sure that you're reading volts or voltage. To set the multimeter to DC setting, we're gonna make sure that this button right here is clicked on, and to adjust the setting to AC setting, we're going to click on the tilde here, or the sign, the little sine wave here. Notice that I still have my 5 volts peak to peak square signal with 0 offset. So I'm expecting the VRMS to be the peak, which is 2.5 volts for a square wave signal, and the mean is 0. So under DC settings, remember the digital multimeter reads the mean value, which turns out to be approximately 20 millivolts. Again, we can round that to 0 volts. If I press on the tilde here, or the sine wave, to change the settings of the setting of the multimeter to AC, I will read 2.5 volts, which is the RMS value for the signal that I am providing. So again, under AC setting, the digital multimeter reads the RMS value of the signal, of the pure AC signal, and under DC setting, the digital multimeter reads the mean of the signal. As a last exercise, I'm going to change the offset to, for example, 2 volts. So now the mean, instead of being 0, I've changed it to 2 volts. So I'm going to run the simulation again to prove to you that under AC setting, we're reading the RMS value of the AC signal, or the AC part of the signal without the offset, and under DC setting, we're going to read the mean of the signal, which turns out to be equal to the offset. Because the signal we're providing is symmetrical, we're simply shifting it up by 2, so that means we're changing the mean by providing an offset. So this concludes the tutorial of this video. If you have any questions, please you can send me a message via Microsoft Teams, or if you were watching this during a live session, you can ask me directly.